Welcome back, guys. In the second half of the class, as I mentioned earlier, we're going to focus in on the topic of our sensory system. But when we talk about our sensory system and how this process develops, it's really important that we understand and appreciate the fact that sensation actually entails two major parts. The first big thing, the thing we typically think of with our sensory system, is the process of sensation. Taking energy from our environment, which comes in a number of different forms, either light waves, touch, pressure, smells, by molecules, or any other type of sense that we have, and converting that energy into a pattern of responses that our brain can actually pick up on. So when we brush our hand against something, or when our eyes pick up light rays, something in our body is actually taking in that information and triggering activation in our brain so we can start to process that information. But in addition to having that sensation process that's critical in sensation, we also need to be able to perceive what's actually going on. It doesn't help to have light waves hitting our eyes unless we know what we're actually seeing. So if you see a face, you know the collection of light waves, the patterns that are presented, and you can actually identify that it's a face. And if you know even more about the face or more details about the pattern, you could even recognize whose face it actually is. For a touch, if we have our system picking up on heat, well, it's great to be able to pick up on heat, but if we don't know what heat feels like, we don't actually know how to react to that. We don't know that we're actually feeling heat. So not only in the sensation system and the sensory system do we need that sensation skill, but we also need to be able to interpret that information. We need to be able to perceive it. And if we master both of those things, our sensory system will work very efficiently and help us interact with our world very, very well. What I thought we'd do today, just to kind of give you a glimpse into why our sensory system and our perceptual system is so good, is play a little game from home. Now, if you're at a coffee bar, you can feel free to remove yourself from this, but what I thought we could do is just have you guys try to mimic a couple behaviors that I'd like you to do, just to see how our sensory system actually works. So if you have a pen or a pencil or a piece of paper or anything in front of you, what I'd like you to do is, first of all, with your eyes closed, reach out, feel for that object, grasp it, pick it up, hold it above your head, and then place it back down on that table. Hopefully, most of you, as we're doing this, are capable of doing that. None of you maybe banged your hands or bruised yourself in the process. And that's because your sensory system is fairly well developed. So you can feel that object that you were reaching for. You can know exactly how hard to grasp it. And you can do all this without using your eyes. But if you do that exact same task now with your eyes, I'll pause so you can try it. If you do that exact same task, as you're probably doing right now with your eyes open, what you should be able to see is that your vision can actually enhance your ability to do this. So you're much smoother at this task when you're involving your eyes, and that's because you're incorporating a second sensory system, your vision, in that process. Another great thing you can do if you want to try this is to throw a ball up in the air and try to catch it, or throw your pencil up in the air and try to catch it. There's actually a lot of systems that are involved in that catching process. You've got your vision, which is something that you should be able to see very quickly, or recognize very quickly as being a part of the system, but you've also got your sense of touch. That's absolutely critical for you to know when to close your hand, when to kind of cradle that object, and how to move around with it. And that combination of vision and touch is very important. But there's also other systems that we can use. So if I were to have you, and this is where if you're at a coffee shop you might not want to fall around, but just imagine how you can fall around with this. Start a beat where I just say clap, clap, and just keep doing this, and you clap in unison with this. Most of you should be able to do it, so let's try it. So as I say clap, I want you to just clap your hands and see if you can follow along if I do at least a semi-steady beat. So here we go. Clap, 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 clap. Now, we've only done it 4 or 5 times, but you should have probably picked up on the pattern of the clapping sound. And most of you, unless you've got a really, really bad sense of rhythm or just weren't paying attention at all, should have been able to clap in unison with me. And that's another product of our sensory system. You being able to hear my voice, process that information, expect when you need to clap, and also knowing how hard you have to hit in order to make that sound. Now, it doesn't seem that amazing, but actually, at birth and as we grow up, those processes are very difficult to master, and it's involved in our sensory systems. In today's class, what we're going to do is focus in on 2 particular sensory systems that develop. Now, we have 5 actual senses that are very important, and we could take 2 or 3 weeks actually focusing in on the development of these particular systems. But since we only have the equivalence of about an hour to talk about this stuff, well, actually a half hour now, what we're going to focus in on is 2 particular systems, our vision and our hearing. Now, touch, taste, and olfaction, or smell, are very important systems, and they shouldn't be neglected. You're more than welcome to read about them and try to figure out how those things develop. But vision and hearing are the 2 systems that are the most prominent in our development. They're the ones that require a lot of mastering of things, and they're the ones that we're going to spend today's class actually focusing on. When we look at vision in particular, the first thing we have to focus on or understand how the sensory system actually works is the product, or I guess the tool and mechanism that we use in order to be able to see things. And as all of you know, the main tool in vision that we have outside of our brain is the eye. And that's because when we use the eye, we're actually using a number of parts of the eye in order to be able to actually process what our eyes and our brain is actually taking in. If you see the picture in the lower right-hand corner of the eye, you're going to see the eyeball and a whole bunch of different parts that are labeled and critical for our visual process. We're not going to focus in on a lot of them, but there are 2 specific areas of the eye that I want you to focus on. The first area of the eye, which is really important, is called the lens. The lens is a small kind of jelly-like structure that's very close to the front of the eye that actually bends and contrasts as we focus in on things at different depths. So if you have something very close to you, your lens will actually change its shape in order to allow you to focus in on that object. If something's very far away, it'll elongate, which will allow you to focus in and narrow down on that shape even more. And based on the movement of the lens, you get to change your focus on different objects. The other cool thing with the lens, though, is the fact that not only do you change your perspective of things and actually be able to adjust to your environment based on the changing shape of the lens, but your brain actually picks up on how much your lens bends in order to give you some sense of depth perception. So you know when something's 20 feet away versus 50 feet away based on how much your lens was actually bending. That's one area we're going to look at with development because it's an area that's not 100% set at birth. The next area that we're going to focus on a little bit later with this concept of development is an area called the fovea. That's an area right in the back of the eye. In particular, it's an area smack dab in the middle of the back of our eye. Now, the location of the fovea is critical because that's where most of our light actually comes in. When we're focusing in on something, when we're looking directly at it, the light that we're getting from our environment, the light that we're focusing on from our environment, is automatically being reflected onto our fovea. If we move around the fovea, there's an area called the retina, which is in the kind of the periphery of the fovea where we can still pick up on light, so we can sense things coming in. But when we pick up on a lot of detail, in particular when we pick up on color, the color of things, we actually are using our fovea. And that's because the fovea contains 2 types of cells called rods and cones. Rods are present throughout our retina. They're all over the place, and they allow us to pick up on different contrasts of light and dark, and they allow us to pick up on things like movement. Cones are only present in the fovea, and their presence in the fovea is due to the fact that they detect color. So anything in our periphery actually is only seen in light and dark, and that's because we don't have any cones out there. The cones in the center of our fovea allow us to pick up on different colors and very small, subtle changes in hues of what we're actually looking at. Now, just like the lens, though, the fovea is very undeveloped at birth. We have very little ability to actually pick up on color and the dimensions of objects at birth because our rods and cones aren't nearly as developed, and the connections between those rods and cones and our brain aren't nearly as formed as they will be when we become adults. If we look at the kind of side effects of the lack of development in the lens and the rods and cones at birth, we can see how this particular system has to develop for us to be able to master the process of vision. In particular, when we look at the lack of lens development, we can see that it has a big impact on something called visual acuity, the ability to see things at a distance. With young children, in particular newborns, the ability to see anything beyond a few inches of their face or even a few feet of their face is almost completely gone. In fact, any ability to see anything more than about 5 feet beyond a child's vision is very, very rare. And that's because at birth, if we're talking about visual capabilities, children have somewhere around 20 to 40 vision, which means what most of us would see at 20 feet away, or the depth of vision that we would have from 20 feet away, what children see from 20 feet away, is about the equivalence of what we would see at 240 feet away, if you have normal 20/20 vision. Now, as children age, as that lens develops, they start to have the ability to gain more focus on objects further away and actually have around 20/40 vision by about 6 months, which means what we would see at 40 feet away, they can recognize at 20 feet away. It's fairly good, but it's not great. Now, as certain people age, that vision doesn't get much better. The lens doesn't work, or the eye shape's not 100% correct, but for most people, we eventually get to about 20/20 vision by about the age of 1. Now, just seeing those objects, being able to focus in on them, obviously doesn't guarantee that we're able to actually perceive and understand those objects. And that's the other big part of the perceptual system. So not only do we have to sense things, which we should be able to do fairly quickly within a year, we also need to be able to understand exactly what we're focusing on. The other thing, though, before we look at the concept of perception, is their ability to pick up colors. And for young infants, a number of studies have indicated that kids might not actually be able to detect color at birth. The cones aren't nearly developed enough for a child to understand the difference between colors. And there's also a large amount of individuals who believe that even if kids could detect differences in colors, which we don't have any indication of in studies, they won't have the ability to understand what those colors actually are. Their brain hasn't picked up on the information related to the different hues that they're actually being presented. In fact, colored vision, or the ability to detect differences between colors, has only been verified between children between the ages of 4 to 8 weeks. They can detect or sense differences between colors in the way their brains react to different hues that they're being presented. However, even though they're able to detect differences between colors, it takes another month to 2 months before children actually show color preferences. So before they choose the blue blanket or the pink blanket or any other blanket that you're giving them, it actually takes a child a long time, almost 4 months, before they actually have a preference or the ability to recognize specific types of colors. So for those of you that are becoming parents and worried about whether or not your daughter gets a pink blanket or a blue blanket, or whether or not there's a blue balloon or a pink balloon, take comfort in the fact that they won't know what the difference between those two colors are for a very, very long period of time. Now, as I stated earlier, though, when we look at depth perception, when we look at the ability to pick up on colors, just having the ability to actually sense those differences isn't the only thing that's needed. You actually have to be able to perceive the differences between those things. And that development takes place in the mind, where our mind is continually developing its ability to pick up on what those wavelengths of color actually mean, what the sounds mean, and all the other things in our environment actually mean in terms of depth and visual perception. Now, one other thing that our brain is also picking up on at that time, though, one really interesting process that has to take place, is the ability for the brain to pick up on something called perceptual constancy. That's the ability to perceive objects of different sizes, different shapes, different angles, as being the same thing. So if you look at the picture to the right on the top, you'll see 3 different doors. Most of us know those are doors. Most of us know probably that it's most likely the same exact door. But for an infant, those will be perceived as 3 different images. Those will be perceived as 3 completely different objects because of the fact that they're 3 different images. And until our brain develops in particular perceptual constancy, that will always be the case. Same thing with the woman below. It's 3 different pictures to an infant because they don't understand the motion of the hand, the fact that it's moving closer, and even when the lens is changing, it's not a different object in order to be able to pick up on that. Perceptual constancy abilities start to develop at about 3 months of age, but it requires a lot more time and a lot more exposure until a child is actually able to master this particular ability. In fact, a lot of researchers believe that perceptual constancy isn't understood until we reach the middle of our adolescent years. Another big perceptual thing that kids have to master is something called depth perception. That's the ability to pick up on the information that they're getting from their lens in order to get a sense of how far away something actually is. A classic study on depth perception is given to you in the picture below to the right, where kids are tested on their ability to recognize that a floor is actually dropping beneath them. There's distance between the floor and that they're not supposed to crawl across that floor. Now, before you start really freaking out and worrying that the child very well might fall over that cliff that the mother's calling him to, understand that in this experiment there's a nice big plexiglass holder on the other side that prevents the child from falling. But what they're doing in these experimental tests of depth perception is seeing whether or not children actually display depth perception in these tests. And for a very young infant, about 1 to 2 months of age, when a mother calls these children, obviously they can't crawl very well, but they can at least sort of move. They will move across the ledge where there looks like there's about to fall off without any recognized concern or any distress that they can't possibly get to the mother. At about 2 to 4 months, though, usually a little bit later than 2 months, but somewhere between 2 to 4 months, a child starts to display an understanding of depth perception. They start to display the recognition that that cliff is something that they can't physically cross because it would be a big fall for them to get to their mother. So after constantly crawling to the mother for a large period of time, these same children at about 2 to 4 months of age will stop. They'll show distress, a lot of them will start crying, and very few of them will edge their way over to their mother because they've mastered the understanding of their lens and also something that we call binocular cues. The information they're getting from both of their eyes tells them that there's depth there, that there's a drop that they have to avoid. And this is another major perceptual development landmark that kids have to pass through in order to really understand what's going on in their visual field. As we age, in addition to developing these perceptual abilities, we also start to develop other sensory differentiations as well. By about 3 to 4 years of age, children start to detect what we call color boundaries, those very subtle differences between colors like black and white and other things like green and red and any other color pair that we have. These ability to detect color boundaries is really important at 3 to 4 years of age because this is what allows a child to actually read. Before that point in time, because children can't recognize the fine boundaries between colors, letters just look like a blur to them. But as they master that ability to detect those boundaries, they can actually start to understand letters. They can start to understand the concept of words at that point in time. We also, as we progress, develop eye muscles and develop structure within our eyes and allow us to not only see distant objects but also see objects that are very, very close to us. So with childhood, we're developing better visual skills both in growth of our perceptual system and our sensory system that allows us to see things. As we get older, move into adolescence, we don't see a huge amount of change in development, but there is a belief that maybe somewhere along the way our perceptual skills are getting slightly better. Our sensory skills are pretty much limited or at our maximum point by the time we reach childhood. As we reach adulthood, our visual skills stay fairly good for a long period of time, but as we get much older, into our 50s, 60s, and beyond, we start to lose a lot of visual functioning. So we lose our visual acuity, ability to focus in on things, ability to see things in the distance. We also lose our dark adaptation. So in night, when you have the elderly people kind of wandering around or trying to focus in on objects at night, what oftentimes happens is they lose the ability to really focus in on those objects and detect those subtle differences between shapes. We also theoretically lose some color vision. For some people, it's much more severe than others. And depth perception is something that tends to be a major problem as well. So picking up on how far something is away from an individual becomes a problem because the lens becomes less flexible, and our ability to detect how much the lens has moved and how much all the other visual cues that we have is telling us something is distant from us becomes much, much worse. One final major problem that we see with age is something that's caused a lot of concern within a number of fields, is the fact that as we age, we also become much more responsive to specific types of light, in particular to very bright lights like glare. And when that happens, when we become oversensitized to these things, we lose the ability to see a lot of other objects when that glare is present. And this becomes an exceptionally big problem for the elderly when we do things that have a high amount of glare, in particular when they do things like driving. And this lack of ability to pick up on depth, this lack of ability to see things in fine detail, and this overreaction to glare is something that's caused a lot of people to rethink the fact that a large number of individuals in their elder years can actually drive. Even if they're cognitively capable of doing things, a lot of times they increase their risk of accidents, and a number of studies have shown that there's a much higher rate of accidents in elderly individuals versus younger individuals because of this lack of vision. And this is something that's universal for everybody, but it definitely varies from person to person. Now, after talking about vision, talking about the development of that system, you might be getting the sense that our sensory system is something that requires a lot of effort and a lot of growth as we age. But before you believe that about every single one of our systems, I want to throw you for a small loop here and talk about another system that actually doesn't require that much development at birth. In fact, a number of studies have shown that despite the fact that we need to really pick up on subtle nuances of things as we age with this particular sense, hearing, it's actually pretty developed at birth. In fact, most of the abilities that we have with respect to hearing are actually present at birth, and that's because, well, at least we believe it's because a lot of these things are developing in utero, or in the mother's womb. Some of the classic things that newborn infants are actually capable of doing, things that we've seen in a number of studies, is things like identify where a voice is actually coming from, and identify a specific voice. So there's a number of studies that have shown when looking at newborn infants and measuring things like sucking rates or the way they turn themselves when they're able to do that, that a child can recognize at birth their mother's voice. They also can not only recognize their mother's voice, but where it actually is. So is it coming from the left or the right? And that's because this particular aspect of our nervous system, both in the brain and in the ears, is fairly well developed at the time of birth. We also can be more sensitive to different frequencies, so high pitches and low pitches, and detect different levels of volume as well. So when something's very loud versus when something's very quiet. So if you're going to have a party at your your house. It's fine to have as many lights as you want with a newborn infant, but don't make much more noise because they are very attuned to that, and they can pick up on those subtle differences in the volume of your voice and the tone of your voice as well. As we age, though, just like everything else we've talked about with our physical development, these hearing abilities that we have at birth do eventually decline. This decline is much, much later than typical decline, but we see in our 70s and 80s that a lot of our hearing abilities do actually decline. Surprisingly, when we look at the decline of hearing, decline of our auditory skills, they're somewhat limited to specific frequencies. In fact, if we look at this chart, which is somewhat tough to understand, but if we look at this chart, what you'll see is a range of different sounds on the bottom corner, which is something that we call hertz, or the frequency of the rate of the sound waves that are being presented to us. Most individuals, when we hear sounds in the voice of range, or in the range of human speech, somewhere between 80 and 10,000 hertz, most of us hear those sounds at about the same level. So something that's 20 decibels, so as loud as, say, leaves rustling, should be something at any one of those frequencies that we can hear easily. But if those 20 decibel sounds are at a lower frequency, below 80 decibels, it becomes very difficult for us to hear it. So the same sound, the same 20 decibel sound, is actually something we can't hear when it's below that 80 decibels. Same thing with a very high frequency sound as well. If it's over 10,000 hertz, it's got to be much louder than 20 decibels for us to be able to actually hear that sound. And it works for all the different frequencies of sound. Actually, it works for all the different decibels of sound. It has to be much, much louder for us to perceive something as loud in the lower and higher levels of decibels. In the lower and higher levels of frequencies in hertz. The surprising thing, though, is that as we age, we'd actually get much, much worse at this. So when we're older, most individuals have the ability in particular to hear things at about 1,000 hertz. In fact, there's very little decline in the ear's ability to pick up on those frequencies. But that curve, that curvature that we see in natural hearing, that's in this picture, gets much steeper. So if anything's below that 1,000 hertz or above that 1,000 hertz, it's required to be a lot louder for somebody to be able to actually recognize those sounds. And as we age, as our hearing gets worse, those low and high frequencies have to be even louder. So when you think of those really cool hearing aids, what they're typically doing for the elderly is just amplifying the sound of the low and high frequency sounds, and that allows them to hear them as if they were normal sounds. But it doesn't amplify those medium frequency sounds because the ears are already attuned to picking up on those sounds usually. As we age, it gets more and more difficult, though, to pick up on those sounds, so we have to amplify them even more in things like hearing aids. That discussion of hearing is where we're going to end today's class. And if we look at kind of that section, we can see obviously a contrast between some of our sensory systems that we have, in particular our visual system and our auditory system. However, definitely just covering those two systems was not the only thing we covered today. Just a review for you when you're looking at your notes, the two big areas that we focused on in today's class, and you'll see it in the adjacent readings, is this concept of motor development, how our body changes, how we actually are able to interact with our environment as we age, and also our sensory and perceptual development, growth, and change. That's going to mark the end of today's class.
And actually, the end of class marks the end of a section of material that we're going to be covering throughout this course. So we've just finished up with our first major topic within the field, and that's our kind of physiological development and how we look at changes going on within the body and how they affect us. In our next class, we're going to be transitioning to the next area that focuses on cognitive change and development. And we'll be discussing the first 2 or 4 areas before the next big exam. So make sure, if you haven't run the readings for this section already, you do that, probably review the physiological or physical development sections, and then get prepared for some new interesting material when we transition to our next big area in our next class. Wish you all the best of luck. Good luck with the write-ups, and I will be speaking to all of you soon. Take care.